idea. Now you got the idea, that is how it works. Now we have to implement it with the help of array. Let us take the array which is linear and it is not a circular array. Okay, simple array like this array. So this is an array. It has the front and rear. So we can add the people here also, and we can add at the, let's say this is there. So we are adding at rear. Now if we want to add from the front, we will add it from front. But in array, we cannot add it because there are indexing. For example, let's say the array indexing starts, and let's say this indexing is right now, it is a 0 indexing. It is 1, it is 2. And let's say this is the array size of n. Then what is the maximum index that is possible is n minus 1. All right. So this n minus 1 maximum index is possible. Now let's assume that your front is here. Front is here. And your rear is here. So can we add at the front? No, we cannot add because there is no space at the front. Because we cannot add it at minus 1 in array. Okay, so if the front is 0, if front is 0, then we cannot add at the front. Now if we delete from front, let's say, delete from front. So what will happen, that this will be deleted and now front is pointing to 1. So front value is now, front value is 1. Now if you want to do add from front, yes, there is a space available at 0th location. So what you will do, you will go one back and add at the front. So now front will point to 0. Now rear is here. Now you want to add at the rear. So there is, it is not equal to n minus 1. Therefore it is not full. Therefore we can add at the rear. So we will increment the rear and you will add a person at the rear. So rear is now pointing to 3. So that it will point to, if let's say rear is at n minus 1 and it is add at rear, then you will say that there is no space. It is full. So we cannot add it at the rear. So what is a full condition? What is a full condition? Full condition is that when rear is n minus 1 and the front is 0, then we can say that the entire queue is full. That is the full condition. And what is the empty condition? Empty condition will be, let's assume that your front initially is equal to r is equal to minus 1, indicating that they are not pointing to anything. So right now let's say this is the queue, and if front is equal to r is equal to minus 1, then it means that it is not pointing, there is no any people in the queue. So it means that it is empty. It is empty. So if now add, let's say NQ, add from front. So what will happen, that here I will add the front, I will add it, and both F and R will point to this location, which is 0th location of the array index. Now I do add again front, add front, but you will highlight the message that it is at location 0. It is not possible to add at front. Then let's say it is selected add at rear. Then yes, you can add at rear. So you will add it here and rear will become now, F is now 0, front value is 0 and rear value is 1. Now you again add at rear. So what will happen, that this will be added at rear and your rear value will be now 2. Now you call a function, let's say delete from front. So okay, so this will be deleted. So that means what will happen? Deleted in the sense that front will move ahead. If the front moves ahead, then this place becomes empty. Okay, so now front becomes 1 and then, so now to add at the front, you have to go to, you have to come to this side to add at the front. And to add at rear, you have to go to this side of the array. See the opposite of it. So in the front, your indexing is decreasing, and at the rear, your index is increasing. While in delete, you are in the front pointer is going here, and the rear pointer is going here. That is, while deleting, front is increasing and the rear is decreasing. Now let us try to implement it with the help of array. Let us take a new project. Let us take it as C++. Yes. So let us take a class. So yeah, using namespace std. Class DEQue. And we have to implement it with the help of array. So let's take array of size n, integer q of size n. So we will define it using microprocessor hash define size, or let's hash define n. N is some 10 locations. All right, hash define n 10. So int q and 10. So we have int front, int rear, and we'll have public functions. So we'll have constructor DEQue. So in that case, we'll make front is equal to rear is equal to -1, indicating that it is, and we will highlight cout the DEQue is successfully created and initialized to empty. All right. So now let us have a function void add front. Okay. So we will add at front. So to add at front, what we will do? Cout /n enter value to add at front. All right. But before this, we have to check it, is it possible to add it or not? So if front equal to 0, if front equal to 0, that means it is not possible, isn't it? Then we can have cout /n, it is not possible to add at front. All right. Else what? Else enter the value seen. So what we have to do? To add at the front, you have to decrement the front. Front is equal to now first of all, if it is a front initially is -1, so we have to add at 0th location. So if front equal to -1, that is the first node we are adding. If it is the first node that we are adding, then front is equal to 0. Else front is equal to front -1. Otherwise, decrement the front and then add at the front. Then q of the front is equal to seen. Cout, enter the value of this, control X. First we'll initialize this, control V, and then seen Q ka front. All right. So we are getting that into front. So we have added at the front, we'll highlight the message, cout /n node or data success is successfully added at the front. All right. Now, so once it becomes if front equal to -1, then both front and rear points to the same location. So also that we have to make it front. Sorry, we can do at the one line itself. Front equal to rear is equal to 0. Rear also points there. Else front equal to front -1. Now let's add the another function, void add rear. Add rear. So to add at rear, so if it is a last person already there at location n-1, then what we will say that there is no place to add at the end. Okay, so we'll check it. If rear equal to n-1, last position, then what is the then what is our measure? Cout /n, there is no place at rear to add at rear. All right. Else what we do in else, rear is equal to rear plus 1. Also we have to check it if it is the first node that we are adding it. If rear equal to -1, if rear equal to -1, that means it's the first node that we are adding. Then in that case, front is equal to rear is equal to 0. That we have to initialize it. Else rear is equal to rear plus 1, and then add cout, enter the value. So cout, enter the value to add at rear, then q ka rear is equal to this, and data is successfully added at the rear. All right, so add front, add rear is done. So what we'll do now, we'll try to implement the display function, void display. So to display it, we have to go from front till the rear. Let's say now front is here, we want to display the entire queue, then we have to go from front till the rear and display the values. All right, so we will have integer I is equal to front for while I is less than or equal to rear, and we have to cout we'll see q of I, and we'll give some spaces. Okay, so to get the on the next line, you can have it /n, the nodes in queue in DEQue are. All right, and then we'll display the, so we'll try to just run this two parts. Okay, and let us have it DEQue with array. So we already have the menu driven. Let us open the file. We'll try to adjust based on what we want. So now, okay, so DEQue, directly we need to create the object obj, no need of pointer. So menu add from front, add from rear, delete from front, but we have not implemented delete yet, just add. Okay, so there is no need to have the creation of the object. Directly you can call obj dot add front, add front. Then there is no need to create. Case 2 is add rear. Okay, so add rear obj dot, since it is directly the object, no pointer. Now I just comment out this, just keep the display. Case 3, case 4, I have to just comment out this, comment out, and then display the function. Fifth one. All right, so done. So now let us run it. 46 lines, 46 we have not completed. Yes, cout was not declared. 14. Using namespace std, where the cout is not declared. 14 lines. Why is it giving error? Copy, the environment is C++, using namespace. Oh, sorry, hash include IOStream. IOStream. Now let us run it. Okay. So now add from front 1. So let's add 5. Now let us display it. Oh, sorry. What we have not done I is equal to I plus 1. Display I is equal to I plus 1. Done. Run it. Add from front 5. Let us display. So we got the node in DEQue are q of I. What we have done, q of I. Why is it not showing the value? Display. Oh, sorry. I have to terminate 6. Q of I. All right, now run it. So add from front 5. Now let us display. So 5 is there. Now let us add from front again 1. So it should give the message that it is not possible to add at front because it is already at front. All right. So now let us add from rear 2. Now let us add the value 10. So it is successfully added. Now let us display it. So 5 and 10. Okay. So now let us add one more at the rear. So 2, let us add 15. So now let us display it. 5, 10, 15. So this is how we can add it. If we go on adding till the last one, rear 4, 4, Now let us display. Enter your choice 9. Okay, 5, 10. Sorry. 2, add from rear. 2, 2, 2, 2. Now let us display. How many are there? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Now let us add one more. Let us add. So it is, now let us display it. So we got 10 values, 3, 3, 6, 3, 9, 10. If we add it one more, then it will show that it is full. There is no place to add at rear. All right. So because the size is 10. Now this is how you have implemented addition. Successfully the addition is done. Now what you have to do? You have to implement the deletion. So what you have to write down? So you have to write down now two functions in this void delete front and one more function void delete rear to delete the data. All right. So what you have to write down? Add your code to delete. Okay, you have understood it now. Delete from front. Okay, so to delete from front, what you have to do? You have to check it. Is it very, first of all, is it empty or not? Check it. Check it. Is it? Check it. Is it empty? So how will you check it? Is it empty or not? So if both are -1, front is -1, rear is -1, then it is empty. If it is not, if it is not, then what you have to do? So front, and you have to check it if front equal to 0. If it is 0, that means it is at the first position. Or you have to delete it, you have to make it front equal to front plus 1. So you have to go to the next location. And to delete from rear, you have to make rear is equal to rear -1. That is to delete it. All right. So you have to add the, based on this, first check it. First check for empty. Then properly delete it and then highlight the message. All right. So that two codes you will add it. All right. So I'll give this code to you. What you do, you just add it and give the definition here. The queue is empty. So let us implement that case first. Okay, so we have a delete front. So I'll just comment out this part. Okay, so what is our first case? First case is that what if it is empty? Okay, then what to do? Then what to do for this? You can check it if how to check it if front is equal to -1, that it is not pointing to anything, it is -1, then it is empty, isn't it? Then we can have a message cout /n the DEQue is empty. All right. Else, now it is not empty. All right. So now another case. Let us see which are various other cases. Okay. Now what we have? So we have this there, and we have only the single element present here, 5, and rest all this they are not filled. All right. So let us take only single element n-1. So what is happening that in this case the front is also here and the rear is also here. So that is the case in which front and rear both are equal. That is the case, that is we have only single element, only one element. So if front and rear both are equal, then we have single element, then we have to delete it. And once we delete it, then what we have to do? We have to make, again, this is empty. And what is the condition for empty? Empty condition is that both F and R must be -1. That is the empty condition. So we have to make this Q empty. So now else. Another case is that what if there is only single element? All right, single element. Then if we have front equal to rear, then that is the case in which we have only single element. So what we have to do in this case? We have to make front is equal to rear is equal to -1. But before that, what we will do? We will store the value and we will print the value. See, that is deleted. So value is equal to Q ka front. Our data structure is, the name of the is Q. All right. So at this location we have got the value. So let us take integer value, and we will print it cout /n the data. Which data is the value? Is successfully deleted from front of the DEQue. All right. Now another case would be that here there is no just one element, but there are multiple elements. What if there are multiple elements? Now let's assume that this is the first position, this is second position, this is third position, fourth position, and so on. So we have element 5, 6, 2, let's say like this. So what will happen? That front is here and rear is here. So the second case would be that here multiple elements are there. So in that case, what we'll do? We will make the front move ahead so that this space will be empty. All right. So we have to make front move ahead. So front will now point to the next element. All right. So let's do that. So another case is that else. Else means here, what if we have multiple elements in the queue? Right. So in that case, what we have to do? Else front is equal to front plus 1. So we have to move front ahead and then just print which data is deleted. So okay, so now let us try to see our delete front. Is it properly working or not? And then we will write down the next definition of the delete from rear. All right, let us run it. Okay, so number 1, add at front. Let us take a value 5. So 5 is successfully added. Now let us display our queue. So we see only one element 5 in the queue. Now we'll add one more element at the rear. So the second element, let's say 10. Let us display it. 5. So we have 5 and 10. Now what we'll do? We'll try to delete from front. So it is the third number case, 3. So the data 5 is successfully deleted from front of the DEQue. Now let us display it. Now we have got only 10 present. Now again delete from front. 3. So the 10 is successfully deleted from the front. Now again display it. So it is showing something, the DEQue R5. Okay, so now display is not properly working. Let us see why it is not working. Okay, so we'll just exit it and we'll see the display. It is showing something which is empty. Have we checked the empty condition in display? we have not checked the empty condition here. What if the DEQue is empty? We have not checked the condition, so we have to check the condition. So how to check it? So if front equal to -1, then we have to check it. Then we have to highlight that cout /n the DEQue is empty. All right, and then else do this part. Do this part. All right.
Hello, sir.
So now add at front. So let's take a value 5. Again display. So now we have 5. Let us add now again at rear. Let us add 10. Again display. So we have 5 and 10 in the queue. Now if I delete it, delete from front. Okay, so 3. So what if the data 5 is successfully deleted from front of the DEQue? Now again display the queue. अब 5 चला गया, अब ये 5 चला गया, तो क्या दिखना चाहिए सिर्फ क्यू में? 10. So we have queue that is only 10. Now again we will delete from front. So the 10 is successfully deleted. अगर मैं डिस्प्ले करता हूं तो अभी क्या बोलना चाहिए उसने बोलना चाहिए कि queue empty है. So the DEQue is empty. All right. Now again I add from front, let's say, and let's say something 15, and again I display it. So the next element added is 15. All right. If I again add from front, okay, so it should show a message that queue is okay. Delete हो गया. Okay. If I add again from front 15 and display front 15. If I again add from front, then it should show that it is not possible to add at front because it is already there at front position. All right. Now if I add one more element 34, add at rear 2, let's say add 34. तो अब क्या हो जाएगा इस केस में मेरे क्यू में? If I display the queue, so I have 15 and 34. Now I delete from front 3. तो अब क्या हो जाएगा इसमें? 15 डिलीट हो गया और मेरा अब ये ऐसे हो गया. तो पहले मैंने 15 ऐड किया तो 15 ऐड हो गया, 34 ऐड किया, 34 ऐड हो गया. ऑलराइट. अभी इस केस में यहाँ पे फ्रंट है और यहाँ पे रियर है. अब मैं क्या करता हूँ? डिलीट फ्रंट बोलता हूँ, तो ये डिलीट हो जाएगा और फ्रंट आगे बढ़ जाएगा. तो फ्रंट यहाँ पे आ गया. डिलीट हो गया मतलब वो ये नहीं होगा, मतलब जगह चली नहीं जाएगी, वो जगह रहेगी. अब मैं ऐड फ्रंट बोलूंगा तो मेरे पास जगह है कि मैं आगे इसको ऐड कर सकता हूँ. ओके, सो इज इट पॉसिबल टू ऐड इट? लेट अस सी इट. ओके, ऐड एट फ्रंट and let us now value add it. Let's say 56. So now 56 got added. Now if I display it, so now I got 56 and 34. So now instead of 15, now here I deleted it, so therefore there is a space, so new value is added 56 at this position. So the queue becomes 56 and 34. All right. Now if I again add at front, then there is it is highlighting that there is no space. It is not possible to add at front because there is no space here, empty. All right. Now another definition that we have to write it: delete from rear. So let us try to delete from the rear. Now you tell me which are the conditions for, again, what if it is empty? What if it is empty? It may happen that it is empty. So how to check it? So we will check this condition: if front, if rear equal to -1, then we have to highlight cout the DEQue is empty. else, it means that it is not empty. Then let us take value from the rear, and we will value from rear, and we will delete this value, or moreover we will remove its reference. Now what if there is only single element? ऐसे भी हो सकता है. So that means if front equal to rear, then what we have to do? Then we have to make front equal to rear equal to -1. Else इसमें क्या हो जाएगा कि नहीं, मल्टीपल एलिमेंट्स है, तो इसमें क्या करेंगे हम? लेट्स से हमें रियर से डिलीट करना है, तो इस केस में लेट्स से वी हैव another case in which 15 is there, 34 is there, 56 is there. So, and this is front, this is rear. So I have to delete from rear. So what I'll do, I'll make rear move to the back. So rear is now pointing to 34. So automatically 56 got deleted because there is no reference to 56. So what we'll do, rear is equal to rear -1. ओके, हमने फ्रंट को आगे बढ़ाया डिलीट करने के लिए, रियर को पीछे हटाया डिलीट करने के लिए, एंड देन फाइनली वी विल प्रिंट दैट द डेटा इज सक्सेसफुली डिलीटेड फ्रॉम द रियर. Data value is successfully deleted from rear of the DEQue. All right, so now let us run it. We have to have integer value. Let us run it. Okay, so now add at front. Let's add the value 7. Now again display the queue. So 7 is there. Again add at rear. Let's take it as 14. Again display it to 7 and 14. All right. Now, so let us add again at rear. Let us add 20. So 20 got added and display it. So we have 7, 14, 20. If I delete from rear 4, so 20 should be deleted. Okay, so the data 20 is successfully deleted. Now let us display the queue. So it should have 7 and 14. Again, if I delete from front 3, so 7 must be deleted. 7 is successfully deleted. All right, and if I display the queue 5, then 14 is remaining. Okay, the nodes in the DEQue are 14. If I delete from rear, okay, 14, let's say rear, so 4, so 14 must be deleted. So 14 is successfully deleted, and if I again display the queue, it should show it is empty. Okay, the DEQue is empty. Now that's it. So we have successfully implemented the enqueue and DEQue operations. Okay, in the display, what we'll do, we'll keep the number of spaces remaining into the queue. Okay, let us try to modify display. What we have to do in this case, there is no need actually. As per assignment, this is enough. It's okay now, we'll not update now. So this is what is the final program for